Hi students, in last class we learned read API, write API, close API and FCNTL API. Okay, now we are going to start up with LSIC API or function. Okay, what this LSIC will do, the LSIC function is also used to change the file offset to a different value. Those LSIC allows a process to perform random access of data on any open file. Suppose you are going to open the file and you can read or write at any position, means you can read or write at beginning or end or in the middle. Okay, the prototype of LC keys, there are two header files and this is the prototype. Offset of underscore t. LSIC is the API, nothing but function. There are three argument. One is int file descriptor. Offset means POS is position whence. Okay, there are three arguments. Okay, and success is return new file offset and -1 or error. Okay, means the success is return new file offset, means if it is success it is going to return new file offset. If it is fails it going to return -1, means it is an error. The first argument file descriptor is an integer file descriptor that refer to an open file. The second argument POS means position specify a byte offset to be added to a referred location in deriving the new file offset value. Means what is the content you should add in the location that is present in POS position. The third argument whence is the referred location, means where you should add the POS content. Okay, there are whence, there are three whence values. One is sick underscore CUR means current file pointer address, means at the current position. Okay, sick underscore set the beginning of the file. Next one is sick underscore end of the file. Okay, these are the three position. Okay, these are defined in the unistandard.h headers, means this whence values are present in the unistandard.h header. Okay, if a LC call will return in a new file offset that is behind the current end of file, two outcome possible here, means they're telling that an LC call result in new line offset that is behind the current end of the file. Means suppose it is in the end of the file, the two outcome possible here. One is if a file is opened for a read only, LSIC will fail. Means we know that the cursor is on the end of the file. Okay, it is in the read only form, means there is no content to read at the end, means the LSIC is fail. Okay, if a file is the file is open for the write access, LSIC is succeeded, means the content is over, the cursor will start from here, end of the file, means we can write something along, that is so it is success. Next, the data between the end of file and the new file offset address will be in initialized with null character. Means we should know which is old content, which is new content. So it is initialized with file character. Next API is the link API. The link function create a new link for a existing file. Means we are going to create the new link for the existing file. The prototype of the link function is hash include unistandard.h, and the link function is int link constant char is the data type star current link means the existing link, and constant char new link means for existing link we are going to create the new link. Okay, means we are not creating the new file here, the existing file only we are creating new link, that's it. Okay na, link ಮಾತ್ರ ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಿದ್ವಿ, ನಾಟ್ ದಿ ಫೈಲ್ ಇಯರ್. ಓಕೆ, ಇಫ್ ಸಕ್ಸಸ್ಫುಲ್ ದಿ ಲಿಂಕ್ ಫಂಕ್ಷನ್ ರಿಟರ್ನ್ 0, ದಿ ಇಫ್ ಅನ್ಸಕ್ಸಸ್ಫುಲ್ ಲಿಂಕ್ ರಿಟರ್ನ್ -1. ದಿ ಫಸ್ಟ್ ಆರ್ಗ್ಯುಮೆಂಟ್ current underscore link is the path name of existing file. The second argument new underscore link is new path name to be accessed to the same file. Means one plus there are two roots ಅಂತ. ಓಕೆನಾ, ಟೂ ರೂಟ್ಸ್ ಅಂದರೆ existing file ge we are going to create new link, that's it. Okay, if this call succeeded the hard link count will be increased by 1. Means the extra one link is added means the count will be increased by 1 only. Okay, the Unix ln command is implemented using the link API. Okay, means ln command is implemented using the link API. Okay, the Unix ln command is implemented using the link API. Okay, here it is the program for ln command implement using link API. Okay, here you can observe that there are 3 header file hash include iostream.h. Okay, next hash include stdio.h, hash include unistandard.h. Okay, then we shall start with main function, that is int main. There are 2 argument, one is argument count and argument value. Okay, next condition, if argument count not is equal to 3 means there are 3 argument, that is command ln new file and old one and new one. There are 3 argument. If there are 3 argument is there means it is not going to execute. Okay, if there are 2 argument or 1 argument means it is not equal to 0 means this content will be executed. If it is equal to 3 means it is not going to execute. Okay, next, if link argument value 1 argument value 2 is equal to -1 means if it is -1 means this value is -1 means this will be executed. Suppose this value is 0 equals -1 no means 0 not equal to -1 means this is not going to execute. We are come out from the loop. That's it. Okay. Next, unlink API. Okay. The unlink function deletes the link of existing file. Means here unlink means we are going to delete the link of existing file. Okay. This function decrease the hard link count attribute of the named file and remove the file name entry of link from directory file. Means in link the hard link will be increased by 1. Here unlink this will be decreased. That's it. Okay. The file is removed from the file system when it is hard link count is 0. Okay, and no purpose process as any file descriptor referring that file. Okay, means we are going to completely delete the file. Means the hard link count will be 0 only. Okay, the prototype of unlink is hash include uni standard.h. That is the header file. Int unlink count char current link means the current link the file of the current link of the file will be unlink means will be deleted. Okay. If successful, the unlink function return to 0. If it is unsuccessful, it is going to return -1. Okay. The argument current link is a path name that refers to an existing file. Okay. ASCII n defines the rename function which does not the similar unlink operation. Okay. The prototype of rename function is hash include stdio.h int rename. It is the function constant char old path name constant char new path name means the new path name will be given. That's it, using the rename function. Okay. Here the Unix mv command can be implemented using the link and unlink API as shown below. Okay. Here these are the 3 header file: hash include iostream.h, hash include unistandard.h, hash include string.h. Okay. This is the we are going to start the writing of new program with the int main. Okay. Here there are 2 argument, that is argument count, argument value. Okay. If argument count not is equal to 0 or string compare, that is string value 1 and string value 2 means either one is true means this will be executed because we use 2 pipeline symbol means or anta. Okay. If this is true or this is true means either one of is true means this will be executed. Else this condition, if link argument value 1 argument value is equal to 0 means it going to return the unlink or argument value 1 will be returned means it going to delete. Okay, this is unlink. Next is start and fstat. The stat and fstat function retrieves the file attribute of a given file. Okay, the only difference between start and fstat is that first argument of the start is an file path name, where first argument of fstat is an file descriptor. Okay, the prototype of this functions are, these are two header files, and you can observe that difference here. Okay, in start and in fstat. Okay, here first argument is path name. Okay, the first argument of the start is file path name, where first argument of fstat is an file descriptor, nothing but f descriptor. Okay, the second argument to start and fstat is the address of address of a struct start typed variable, which is defined in a system bar start dot h header. Means for this two, means for second argument, the struct state typed variables are defined in this header file, which are the struct state that are declared here. Okay, these are the structured state. Okay, file system id, file inode number, content, file type and permission, header link count, file user id, file group id, contains major and minor device, file size in bytes, last access time, last modified time, last status time. These are the struct state which can be declared in second argument of the state and f state. Okay, here the return value of both function is 0 if it is success. Means the function state and state is success, it going to return 0, otherwise it going to return -1. Okay, the error contain an error status comment, nothing but -1. The L state function prototype is the same as that of state. Int L state constant char path name and construct stat v. Okay, we can determine the file type with the macros as shown below. Okay, here you can see that these are the some of the macros. Okay, regular file, directory file, character special file, block special file, pipe or first start file, symbolic link or sockets. Okay, these are the some of the macros. S underscore is reg means is regular, is directory file, is character file, is block file, or is input output file, or is link file, or is a socket file. Okay, these are the macros and type of files are shown here. This is end of start and fstat. Next API is access API. Okay, what is the use of this access API? The access system call checks the existence and access permission of user to a named file. Means it is exist, the file is exist or not, it going to check, and what are the access permission also it going to check. Okay, the prototype of access function is hash include unistandard.h int access constant char path name and int flag. There are two arguments. One is path name, second one is flag. Okay, and success of access it going to return 0. Means it is success means access API or function is success means it going to return 0. Otherwise it going to return 1 means -1 means it going to fail anta. Okay, the first argument is path name of the file, means it is path name. Okay, next one is flag, second argument. Okay, the second argument flag contain one or more of the following bit flag. Okay, the bit flag are, there are 4 type of flags. F underscore OK means checks whether a named file exists. R OK means test for a read permission. W underscore OK means test for write permission. X underscore OK means test for execution permission. Okay, here the for example, this is the example. The flag argument value to an access call is composed by bitwise ORing one or more of the above bit flag as shown. Means we can combine one or more flags in the second argument. Okay, int rc is equal to access. Okay, means we are going to access the existing file. It is the path name of the existing file, and these are the two flags. Okay, if it is, if this file is there means, okay, we can test for the read permission and we can test for the write permission. Okay, example to check whether the file exists or not, and we can check the path name ಕೊಟ್ಟಿದ್ದೀವಲ್ಲ, the existing path name contain the file or not, we can check. How we can check? If access, we should give the path name and f OK is the flag, mean nothing but checks whether the name file is exist, means this is the named file, it is present or not. Okay, suppose if it is not present, we are going to get the -1, means it is equal to -1, means it going to print the message as file does not exist. Suppose the file, the given path name is exist, means it is given non -1 value. Suppose 0 1 2 like this. Okay, 0 is equal to -1 no, means else part will be executed, nothing but file will be exist. Okay, means file exist anta print agutte. If -1 is the value for this part, means then file does not exist anta print out. This is access API. Okay, in next class we are going to discuss chmod, fchmod API, and ch1, fch1, lch1 API, and utime functions API we are going to discuss in next class. Thank you.